Let's talk about LEL and UEL, lower explosive limit and upper explosive limit. For this example, we're going to use methane, which is natural gas. So on the scale, we have methane from 0 to 100%. So no methane, all methane. If I have methane in the air in a concentration below 5%, it will not burn. If I have methane in the air in a concentration above 15%, it will not burn. Too lean over here, too rich over here. Not enough fuel, not enough oxygen. So for example, let's say we had 1% methane in this room, and let's say I took out my Bic lighter and I flicked my Bic. Nothing would happen. Let's say I had a breathing apparatus on, and let's say we had 50% methane in the room. And I took out my Bic lighter and I flicked my Bic, nothing would happen. If I had 10% methane in this room and I flicked my Bic, they probably wouldn't let me in this room anymore. So we also have to talk about percent LEL. Percent LEL is also a scale that goes from 0 to 100%. If I have a 0% LEL, I have 0%, in this case, methane. If I have 100% LEL, I have 5% methane in this case. This scale is this little scale expanded. So if I have 50% LEL, that's 2.5% methane. So when you have a combustible gas monitor or an LEL monitor, it will have 2 alarm set points, 10% and 20%. So below 10%, you need continuous monitoring for hot work and cold work. Above 10%, you're not allowed to do any hot work, it's cold work only, while wearing a positive pressure SCBA or SABA. Above 20%, all work stops. Where people get confused is they confuse percent LEL with the actual percent of the gas. So if I have 20% LEL, it's actually closer to 1% of the actual concentration of the gas. Every gas is slightly different in their LEL and their UEL. So that'll change. If it's calibrated in methane, it won't be as accurate